I hope I can give everybody a few ideas for thought today. To continue where you left off, I actually was thinking about the fact that much of what I wanted to say, what I will say today, is trying to give you some perspective. Because after having taught environmental science for 20 plus years, it appears to me that often, and it's not your fault because you're young and I'm old, so I had lots of experiences in that time, that often the younger folk don't yet have the right perspective, what I would think, the right perspective, which is sometimes a longer perspective, sometimes being a little more relaxed about things than when it seems the panic of the day, because I have been through many panics of the day. So that's my subtitle here. It's actually a little bit alluding to that, because I have, and we see that in the news, and you'll see examples here in a moment, we have a lot of people panicking about, I'll call it loosely now, the environment and the situation we're in, and their future. And then we have those that, for different reasons, I will, some of them speculate a little later. Then we have those that say, yeah, balderdash, this is all made up hoax. We don't have to be concerned at all. Be unconcerned. And if some of you are here unconcerned, I hope too that I'll move your thinking a little bit. And what I call the rest of us, I always am an optimist, and I hope that most people are fact-driven and a little bit thinking about things. I know that not most people are, but hey, I can have my illusions too, okay? Let me start by asking you something, because it has to do with my title. Can those of you who think we need to save the Earth raise their hand? Well, look at that, about half of you. I hope that in about 5 minutes from now you'll realize the error of your ways. But we'll see. Let's go into it. You definitely are not alone, folks, that you just raised your hands, okay? Now that quote is not correct, but the opinion says it is. Washington Post, January 19, the world will end in 12 years. She's absolutely right. Technology correspondent in Sky News. Sky News is a British news outlet, 2016, not too long ago. When the oceans rise and the world ends. That makes my skin crawl already. Then I found this is probably not so widespread, I don't know, it's an Australian news hub. What caught my eye was this. Scientist claims humans don't have 10 years left thanks to climate change. Quote, I can't imagine there will be human on the planet in 10 years, he says. We're heading for a temperature within that span that is not at or near the highest temperature Earth experienced in the last 2 billion years. Oh boy. Sorry, I don't have a remote for that, but you know, that's my professor marking for that. This is, and I'll be polite, this is not correct. This is wrong, because it's okay. It's okay if you want to. Next slide. Okay, I'm not used to that. That was when I was a college student. They had their assistants. Okay, now for those of you who have not been, and it's not your fault if you haven't been in an earth science class or in a class that dealt with biology or the history of life, you probably don't know this, but wow, we know that about 500-600 million years ago, Earth was covered in ice all over. It's called Snowball Earth. You have heard of this, I'm sure. You know, occasionally Earth has major catastrophes to deal with, and it has survived them all. Earth has survived being frozen. Earth was very hot. Life has survived major catastrophes. And so, you know, when someone says, oh my God, you know, it's getting warm, there was rapid global cooling, global warming, rapid global warming, so-called nuclear winter. Look at that, 80% of the species gone. 95%, the Permian mass extinction. I mean, you'd think this is the end. 95% of diversity on the planet Earth is gone. And yet, here we are, flourishing planet. So, should we be concerned about planet Earth? Of course we shouldn't be. Earth will be fine. I also say life will be fine. So, next one. What we actually should be, of course, concerned is This is what we actually mean when they serve the earth. It's our civilization, it's our way of life. We notice, many of us realize something is changing, and we have built our civilization, our way of life, on kind of constancy, because we have a very short life, geologically speaking. So, and I say an apology here. That's the apology for my catchy title. You know, if you feel misled, I misled you, yes. It's not about saving the earth, because that's a nonsense catcher. But that attracts people. So I'm happy I have you here. Let's move on. I want to start with removing some misconceptions that people have. One of those deliberate or not deliberate misconceptions that we often find in the media is that weather events are hyped as climate events. This is just a storm here, and you all know what weather is. If you can have the next click. Weather is, you should know that, the short-term, day-to-day, year-to-year sometimes, tropospheric condition in an area. That's the weather. And there's some years where we have a warmer summer, some years we have a colder winter. It all varies. Some years are wetter, some years are drier. That's not climate. Climate is the long-term change. Decades usually could give us an indication when we look at our lifetimes. It's a long-term change of average temperature and precipitation in an area. Now, those of you who studied a little biology and ecology, you know that that's important because the average temperature and precipitation determines what kind of climate zone it is, what kind of organisms will live and thrive, and what kind of organisms won't live and thrive. But climate is not weather. And so there's also, if I can put that in, when someone says, this hurricane was certainly caused by, or not certainly, but people sometimes there's a headline, Hurricane XY caused by climate change. This is an indication that climate change is happening. There's lots of indications that climate change is happening. Don't get me wrong, we'll get there in a moment. But it's not a hurricane. At least scientifically, this is, at best, a little wishy-washy. That's the same thing as saying Mr. X's cancer is caused from a pack of cigarettes he smoked 5 years ago. We don't know what caused a lung cancer. If Mr. X or Y is a habitual smoker, a chain smoker, then it's very likely that the lung cancer was caused by smoking. But it's not even 100% certain. So if more hurricanes occur, which would coincide with some of the predictions we make for a warmer climate, yeah, it's likely there is a connection, but it's not certain at all. Okay, so can we move on a little bit? I looked up the NASA definition, and it's a little more sloppy, but it says the same thing. Difference between weather and climate is a measure of time. So weather is short period, as you can see here. Climate behaves over relatively long periods of time. So that's the important part, because I'm going to talk about time here a little more, and I hope I can give you also some perspective about different magnitudes of time. Because again, we're thinking, how old does the average human get? 70, 80 years. We're thinking less than a century, and that's a long time. It is not in geological terms. Can we move on? So, next misconception I like to talk about, that's one of my students know that, one of my peeve claims that I make, especially on when we go on our excursions. People feel like we need to preserve everything as it is, or was. And if we don't, oh my golly, all hell breaks loose. There is a little bit of sentimentality to that, and there is a little bit of, I understand the psychology. Yes, I love the way things are. I have my favorite places out in Mother Nature. I'd hate to see that change suddenly in my lifetime. But again, on a bigger perspective, do we? We say, oh my God, we must save the polar bear. And don't get me wrong, I love polar bears, and I wish they would be okay in maybe 100 years. I don't know if they're okay, maybe not. But you know, maybe I would have loved mammoths too, or saber-toothed tigers, or you know, other species that don't exist anymore. So it's a perspective thing. Can we have the next click? If you learn one thing in biology, or one of the main things that you should learn, is that change is the only constant in Mother Nature. It always changes. Now, the change is good for some and bad for others. That's the other thing. We are very anthropocentric, and we should be looking at it from the human perspective. But in a general way, first of all, I'm with Jurassic Park. I'm with Michael Crichton. Life finds a way. The big catastrophes in the past have shown it. I'm not concerned about life. I said that earlier. Species come and go. I mean, if you look at evolutionary history, paleontologists, what they dig up, most of these species are no longer here. All we know as humans is a flash situation. This is taken from a textbook. I will not bore you with this long or anything. These are the mass extinction points here. And the width of these spaces shows you basically the number of living families. Families as the unit of, in biology, as the unit of relatedness. One of those, okay. So what we see is after each event, diversity is reduced of biological species and families in this case, but then it bounces back and bounces back and bounces back and actually bounces back beautifully. It's just others that profit from these things. So, as you know, the last major catastrophe, ended what is called the reign of the reptilians, of the dinosaurs, and mammals flourished. And we are one result of that change. Nature changes. So, big perspective. As you will see, I'm convinced, and I hope you will be too when you acknowledge the facts. We are currently doing a big human experiment by quickly changing something here on planet Earth. But we shouldn't be concerned about life, I feel. I feel what we need to be concerned about is us, and that's the more honest discussion we should have. And that's why this is a political topic, as you will see. Can we go on? Okay, I kind of addressed it already. I will not go into that. But definitely anybody who claims we only have 10 years, 15 years, or 20 years, or whatever, to completely change our way of life, because now we are suddenly in a crisis, and that's because I'm 60 and you're 20. You see, that may be different, but nah, we're not more or less in a crisis than we were 20 years ago or 30 years ago. Calm down. No need for panic. Do we need to change things? I'm sure we need to change things. But we do not change them in just a few years. And actually, and I'll have a few thoughts for you on that later, I think we cannot change them in just a few years without tripping ourselves up in a major way. Can you go on? Good. Long-term perspective. Let me first explain what this is and where it comes from. This is from a lecture that you can watch online. It's one of the Howard Hughes Medical Institute holiday lectures. It's about planet Earth. If you can click again, please. Given by Dr. Daniel Schrack. He's professor of Earth and Planetary Science in Harvard, and the guy has spent his whole career looking at long-term climate on planet Earth and on some exoplanets like Mars and Venus, actually. So I want to point out something to you. First of all, this is the scale of 70 million years. How can we dig back in the climate 70 million years? For crying out loud, there wasn't even human there. What they do is they drill cores in the deep ocean, ocean floor cores, where there is sedimentation of organisms. In the oceans we have lots of organisms that build calcium shells. Apparently, when you analyze the oxygen that is in the calcium carbonate there's a method where they look at an isotope of oxygen, O18, and compare that to O16, which is the regular isotope. Long story short, it's like a thermometer. The relative amount of that O18 tells them what the temperature was when that calcium carbonate was formed. And you can dig very deep in the ocean floor, and the deeper you dig, Earth science, the older the sediments are. So they were able to go back 70 million years roughly where they were digging. And they analyzed the temperature, and they analyzed or determined the CO2 via proxy. Proxy means there are methods, indirect methods, again with the oxygen and the temperature, that let you calculate that. Now, in a 1-hour talk, I cannot really go into detail in the methods, but you can look this up if you look up Schrack and his work and all that, if you're interested. So let's look at the result. First of all, I like to simplify things often in my classes to make them more obvious, because I'm a big picture guy. Big picture, what is that? First of all, this is temperature in Celsius. This is taken from the deep ocean floor, remember? 0 Celsius is basically freezing temperature of water. First question someone might have, that looks as if right now the temperature, or close to now, is a little below freezing. How can that be? Is the ocean floor frozen? It is not, it's salt water, and that can have temperature of little less than 0 degrees Celsius and be not frozen. It's just very, very cold, close to freezing. What's the trend? If I look at the last 50 million years with a very rough lens, the Earth has cooled down over the last 50 million years. You see that. There was a warm age about 50 million years ago. That's why I circled that here. And that warm age, look what they found. Other than these data that kind of like support that, namely crocodile remnants in the Arctic, pine forests in the Antarctic, palm trees where we have Wyoming right now. There's indications that the sea level was about 100 meters higher, in other words 300 feet. And yes, Florida 50 million years ago, what would be Florida in the future, was seafloor. We were underwater, which we may or may not be again. Probably we will. But do we remember something else? 50 million years ago, that was about 10, 15 million years after that big comet and the dinosaurs. That was a time where life flourished on Earth. So by golly, even if we're headed towards a real drastic warming up of the planet, again, there is no reason to believe that life is doomed. Okay. I would say there's even no reason to believe that human life is doomed. It would be vastly different, though. And I'll come back to that. So you see that? So there has been an overall cooling trend over the last millions of years. And you see ups and downs, and I'll talk about those in a second, a little more. And the CO2, let's look at the corresponding CO2, because some of you may have heard, and that's correct, that the percentage of CO2 or the amount of CO2 in the atmosphere has an influence on global temperature. CO2 works as a trap for infrared radiation, which in turn is actually warming radiation. And so we know that, we've known that for over 100 years, and it's called greenhouse effect. And it's called greenhouse effect because the first time this was experimentally looked at was in greenhouses, where botanists put different amounts of CO2 in greenhouses and actually saw that they would develop different temperatures under the same sunlight. So how about the CO2? Right now, the CO2 close to our time, it's about 300, 400 parts per million. As you can see there, about 50 million years ago, it is in the neighborhood of 1,000 or a little bit above 1,000 parts per million, so more than twice what it is now. Now, I really don't want to give you the impression that I say nothing significant is happening. What I want to say is, it's not going to be the end of it all. Can we have the next one? So, there are a few things we know, and then there are quite a few things we don't know. We know, and there's, again, for all we know is scientific evidence, that humans, and especially our fossil fuel burning, the age of fossil fuels, coal, oil, natural gas, that is driving up the global content of carbon dioxide. Check. We also know that high CO2 levels will drive up global temperature. Check, no doubt about it. And knowing this and having a little bit of good science that we have developed over the last 200-300 years, we can even predict certain changes in general. We can predict, and there will be a slide, changes for the ocean levels, changes for weather patterns, climate patterns that might change. The thing is that we cannot predict, at least when scientists are honest, is when exactly the changes, the significant changes will occur, other than creeping processes, and how fast those changes will occur. Some of the changes are not linear. In other words, There are models that indicate, if you cross, and you've heard that probably, certain thresholds. There's discussion if we heat up the Earth more than 2 degrees or 3 degrees on average, all kinds of bad things will happen. So there are thresholds that people think they can predict, like maybe the Gulf Stream, the North Atlantic circulation, no longer being what it is right now. But can we say this will happen in 10 or 20 years? I don't think anybody can say something like that with certainty. With certainty, we can predict things will happen if the trends continue, but not when they will happen. Little backflash to having been around and interested in that stuff for a while. In the 1980s, there was a study initiated by the United States government. They called it Global 2000. I don't know if some of the older folks here remember that. And I snatched up a book immediately. And there were primitive computer models about, what will happen if humanity continues on the way it does continue. And guess what? Pretty much exclusively all of these models predicted a collapse of the food supply or a collapse of society shortly at or around the year 2000. Well, yet here we are. What was the problem? The problem was not that these models were completely wrong. The problem was that there was this certainty, this will happen. Okay. Now, it didn't happen, and maybe they would have been right. I don't know. It didn't happen. One of the things why it didn't happen is people became aware of it, and politics started to adjust to it. Societies started to adjust. There were environmental laws enacted, and other things happened. I will not talk about Global 2000 now. All I want to say is most of the doom and gloom predictions that I have been confronted with growing up and in my lifetime didn't come to fruition because especially when they were specific as for the time frame. So take that with a grain of doubt. So another time perspective, this is only 1,000 years, okay? I thought I'd show you 1,000 years of carbon dioxide in the atmosphere. You probably have seen graphs like that. Notice that roughly here from the year 1000 to give or take the year 1800, we have a little bit of ups and downs, sometimes a little bit more down, a little bit more up, but basically the CO2 level stayed around 280 parts per million. And then something significantly changed. Obviously, in the mid-1800s, this is 1800 and, 1850 here, 1900 and 1950. From the 1950s on, we measured CO2 directly, so this is all indirectly. There are many methods how you can go back and measure that. But when we measure it directly or indirectly, you see something significantly happened here. We have been shooting up in our CO2. Well, what happened after about 1850, 1900? The fossil fuel age, okay, that happened. What else can bring, does anybody know what else can bring CO2 in the atmosphere in large amounts?
Methane.
CO2.
Oh.
Methane is a different issue. It's very potent, yeah, but CO2.
Decrease in plant life?
What's that, please?
Decrease in plant life?
If plant life was suddenly drastically decreased, that would be the case, yes, absolutely. Anything else? Not many people with earth science histories here, huh? Volcanism, folks, volcanoes, okay? Big volcanic eruptions. And you guys have heard of Pangea and stuff like that, right? Supercontinent, breaking apart. Well, guess what? These things don't break apart and just nothing happens in a little rumble. This is thousands of years of lava and eruptions and volcano chains and what have you. So that's, when geologists look at CO2 and look at the past, that's where the CO2 comes from. And then we'll talk about that in a second. So, but what I want to say is we certainly know that the last few hundred years, there was no massive volcanism on Earth. There's the occasional outbreak, but as you will see, nothing that would explain this. And the only other source of CO2, the only other massive source of CO2 is human-driven fossil fuel burning. So, all right, let's move on a little. I will not stay long on this. This is even, as you can see, a simplified diagram. Let me tell you, for me as not an earth scientist, this is also, sometimes I'm like, oh man, so this interacts with that and this with that. It's not very straightforward, but I want to tell you the main story here. In red, you see what they call the fluxes, the movement of carbon, and it's mainly carbon dioxide here. So if we look first at the oceans, there's a lot of CO2 and carbon coming out in the form of CO2 out of the oceans. And by the way, the units are petagrams per year. Petagram is kind of like one of these things that it's a lot, okay? It's billions of tons. I'm not going there. But just look at the simplified numbers. So 90 petagrams per year out, but the ocean's uptake is on average 92, or can be 92. So the oceans can take up a little more than they release. What else do we have? Here's photosynthesis. You know photosynthesis, right? Uses CO2, is CO2 sink, about 120 per year. And then we have litter fall. Litter fall is basically all those leaves that fall every year and other stuff. And we have plant respiration. Plants also produce actually CO2 via respiration. Well, you add this up. Plant respiration comes from plant respiration is here. The litter fall is then decomposed by bacteria and decomposers, and that makes then 60 petagrams of that. Well, if you add up the numbers, 60 and 60, that's 120 going up, 120 going down. And there's a little bit of carbon and carbon compounds going into the oceans via rivers, and then there's a tiny little bit dug into sediments. So what is the other stuff that adds CO2? Forest fires, but that's about, look at that, about 1 petagram. Volcanoes, on average, now that's an average, that's not a big volcanic event, but 0.1. And then we're looking at human fossil fuel release, about 6 petagrams. Now, the argument has been made, I have read that, by people who are so-called climate change deniers, said, oh look, there's a release of 90 petagrams by the oceans, and soil respiration 60, and there's all these large numbers, and we only contribute 6 petagrams. It can't be the humans that are responsible for the increasing CO2 in the atmosphere. But here's the dirty little secret. Yes, it can. Because nature has like, if you study A&P, you hear about homeostasis, adjustment, negative feedback loops, where too much of one thing is compensated then by other factors that bring it back. Kind of like balances that shift all over the time. And there is a fairly good balance when you look at all these numbers, and I'm not going to dissect these numbers apart now more, but here's the point. If you add just every year 6 of those, a little bit can be extra taken up here, a little bit can be going in here, but there's whatever the rest is staying up here. This is the big reservoir, one of the big reservoirs. A much bigger one is the Earth's crust and the ocean. But so in other words, we have observed, remember that curve of the CO2 going straight up, that kind of straight up, that's what we find more in the atmosphere. And that comes from the only source that significantly contributes among all the other balances into the atmosphere. Go on. This is another, these are ice core climate data, and I just wanted to point something else out. This is a shorter cycle here than the one we saw with the 70 million years. This is less than 1 million years. This is less than 500,000 years here. This is temperature and this is CO2. One thing that is easy to see is temperature and CO2 kind of like rise and fall together. Although this is misleading, some people make the argument, oh, here you see how CO2 is driving actually the temperature on Earth. This is caused by something different. People have observed a while ago that we go between warm ages and ice ages, okay? If you look at the temperatures here, this is warm age, this is ice age. But it's very cyclical. Look at that. I'm just looking at warm ages. Roughly 330 million years ago, big warm age. 240 million years ago, big warm age. 140 million years ago, big warm age. Well, what is that? It's about every 100 million years or so that there is a big change in climate. It was actually discovered many years ago by I'm still thinking Yugoslavia. I think he was a Serb. Maybe he was not. There's 5 nations there in former Yugoslavia, or 6. But anyway, a guy named Milankovitch. And they're known as the Milankovitch Cycles. Now, what is that? That has to do with the Earth's distance from the sun and the tilt of the Earth's axis. These are long-term astronomical cycles that basically force the temperature on Earth either a little down or a little back up. And they are responsible for the ice ages and the warm ages in the past. If we go on to the next, okay, can we go back? Great. Now, first of all, what is happening here? Where are we in the cycle? We're not yet really at the beginning of a huge, here's the temperature. We're not really yet at the beginning of a huge warm age, and if we were, and the CO2 is corresponding to it, we would expect it to be here. Now remember, this is, although it says 0 here, this is 50,000 years ago, so 40, 30, 10, 5, okay. So this is just the last 1,000 years, which we looked at, and actually this is only the last 150 years, what we see here, or 100 years. We see what happened. Poof. This push has nothing to do with the Milankovitch cycles. This push is, again, the push of burning human fossil fuel. Not human fossil fuel by humans. And I had this again. I'm going to go away from it in a second, just to remind you. So what we're seeing, this up and down you've been seeing, is basically a wiggling, a little wiggle left and right, if you like, that is built in due to the astronomical Milankovitch cycles that either heat or cool Earth a little more. But this has nothing to do with the long-term trend. Now again, coming back to this, the long-term trend is the planet has been cooling. And geologists, when I ask geologists, why do you think this has happened? An explanation I have heard, or an attempt of an explanation is, well, we had no continents really ripped apart recently. We had no huge collisions, no major volcanic or astronomical events, damages to happen to the Earth. We had a relatively stable ride in the Eocene. And that's kind of like what it is, okay? That's why we don't have something, something happened here, okay? But it's not a geology lecture. Okay, so can we go on? And this will be the last slide, I believe, that deals with climate change. And then I will talk a little bit about the other topic that I have. But this is about predictions. It's one of the last slides. We can make predictions, I said earlier. So the predictions, these were NOAA, the National Organization for Atmosphere in the US here. So the predictions are fairly straightforward, and I used a simplified slide. Of course, we would predict if it gets warmer overall on the planet because there is more CO2. Glaciers should shrink, snow cover should be less, temperatures over land should go up on average, humidity should go up, sea ice should go down, and so on. You see this here, sea levels should rise. So those predictions are good and accurate. The only thing we can't predict is going to be, in 10 years it's going to be 10 inches higher. We don't know that. Or half an inch, or a tenth of an inch. We don't know. If we can move on. I found this actually not too long ago in the Wall Street Journal. It's again NOAA as the source. That was about a month ago. First I thought, this is busy. I don't know if that is good for people to see this because it's confusing. It's actually not. It's great after I looked at it for more than 10 seconds. So what are we looking at here? We're not looking at temperature. We're looking at variation from each month's average 20th century temperatures. So here's 1900, here's 2000. So they took the average from 1900 to 2000. That average is somewhere in the very light blue to very light yellow color scale. And the further blue it gets, or the deeper blue it gets, the cooler from that average over 100 years the measured temperature was. And the further into the red it gets, the warmer from that 100-year average it was. And if you look at it with the big eye. Notice it's lots of blues here. So from 1880 to about 1940, the average temperatures nearly every year in every month were below the average of the whole century we had. And from about 1940 to about 1980, it's kind of like close to the average. We see some blues, we see some light yellows, maybe a tad warmer than the average. But then clearly from 1980 to about 2000, we are consistently above the century's average. And boy, oh boy, from the 2000s to about now, we are not only consistently above the average, we are actually getting way above the average every year. You see, every month of every year is here. This is the worldwide temperature averaged. So this is from colder than average to warmer than average. And this is not weather, folks, this is climate. Okay, because this is over decades, here the average of a century taken. So we know the global climate is changing. We know that it is the only culprit, so to speak, the only suspect that we can see is the extra CO2 released by humans. All right, let's move on from that. Just for evidence a little more, it's Snow and Ice Data Center is very interesting. What they report every month or so. They report the ice extent, and actually this is in the Arctic summer. September is the Arctic summer. And you notice it goes up and down, and there's different years. I remember in the year 2007, the press was full and said, the Arctic ice is so low, by 2020 there will be no more Arctic ice. But guess what? It goes up and down, zig and zag. But it doesn't go zigzag on a straight line. It goes zigzag on an average line that goes down. And so while 2020 is probably not an Arctic without ice, definitely sometime in the 21st century, we very likely see an Arctic without ice. It's a downward slope. I was looking for data that bring us closer to 2020. So if you have the next one. They only had that for the Arctic winter. January is the coldest month in the Northern Hemisphere. And there's more ice in January, obviously. This is about twice the ice. You see, here's the ice, about 7 million square kilometers, and here's about 15 million square kilometers. So there's about twice as much ice in the winter as there is in the summer in the Arctic. But the trend is the same when you look at it. Of course, there's a difference from year to year. By the way, here's 2007 again. Another very warm year globally was 2017. I think that was the record heat year so far we have measured. And it goes up again. But look at the trend. The blue line is the trend line. And the trend doesn't lie. The trend is ice is vanishing in the Arctic. Yes. And that means bad news for the polar bears. Just saying. Okay, let's move on. So, second part of my talk. So much about the Earth and bioscience. Question is, I asked you at the beginning, do we need to save Earth? And that's kind of like the battle cry of a lot of people in politics. And the other battle cry is climate change hoax. Nothing's happening. So this thing is political. We all know that. Let's not kid ourselves. It's a very political ball. Why is it so political? And I think we all know it's not about the planet, but it's so political because actually it forces us to reimagine and contemplate our way of life. Because somehow our way of life, and you're not guilty of that, you're too young, I guess I'm a generation you could call guilty, but I'm a little light. I'm not influencing the levers of power, so I call myself innocent too. But that generation that I am with and such, something has drastically changed. Because if you remember with the increase of the CO2, that big increase happened pretty much in the 20th century, and we can be more precise after the 2 world wars. Okay, if we can go on a little bit. So what has happened? And I'd like to remind everybody, if you're not really consciously thinking about that we, and not only us, we and Japan and increasingly China and India and Europe, We all live in what is called a consumer society. And these consumer societies all are based on fossil fuel use. Yes, we use solar. Yes, we use wind power. If you look at the statistics, it's creeping up, I think, on 10% maybe of our power generation, if I'm optimistic. But if you look, the majority of power that's used, fossil fuels in all these countries. So we're a consumer society based on fossil fuels. We create lots of waste, you all know that. And we create more waste than we recycle because, yeah, it's the way we are. And boy, isn't that the mantra? And it's not just the mantra in the US, it's the mantra worldwide in economies. And I'm not an economist, but the mantra is, if the economy doesn't grow, we're in trouble. It has to grow, grow, grow. What does grow mean in a consumer society? People have to constantly buy products and use them. Now, I'm not saying we shouldn't do that, no more products, no more using it, because, well, think of that consequence for a second. Not only would you probably not be too happy, but there would be mass unemployment because, again, where do a lot of people work? A lot of people actually produce, or at least in this country, more sell than produce products that are produced somewhere else. If those products are not sold anymore, they're all out of a job. Because honestly, we don't have enough universities that are financed somehow. We can't all be university professors. I don't depend on this cycle, but I'm a little minority. The economy depends on it. Have you heard of obsolescence? Have you heard of planned obsolescence, anybody? Not too many. There's a great video on YouTube that I recommend to everybody. It's titled The Light Bulb Conspiracy. 60 minutes, an hour. Excellent, if you have a chance to watch that. In a nutshell, obsolescence is the built-in end of life in a product, okay? That something is made, a printer, for example, is made to fail after some time. A computer is made to become obsolete after some time, because even if you upgrade it at some time, it's just, I don't know if anybody works on a computer built in the year 2000 anymore, probably not. They become obsolete. Lots of products become obsolete. And perceived obsolescence is basically, keyword, good example is fashion, perceived obsolescence. What you guys wear today and think is in will not be in 10 years from now, it will be even in 5 years from now. Fashion changes constantly. This shoe this year, this smartwatch that year, the newest phone. Not that the old iPhone doesn't work anymore, right? But it's just so shitty compared to the new one, right? And so that's obsolescence, planned and perceived. It drives us to buy new products and discard old products. And it drives our economy. It makes a lot of people have a lot of money. It makes the state get a lot of tax money. But yeah, we are also running into trouble with this model of having this way of life. Can we go on? So, and now I want to complicate our thinking a little bit, because so far it seemed very straightforward. The answer seems clear, right? All we need to do is change a little bit in our way of life and reduce fossil fuels, and all will be cool, right? And unfortunately, the answer is, nah. We have to think a little further. So, first of all, I'm writing here more humans, and I'll come back to that in a moment. That's like an elephant in the room, because so far I have totally neglected to tell you that humanity is growing immensely still. I mean, yeah, we're supposed to peak at the end of this century, but what, at about 10 billion? Right now we're 7 billion. Okay, so actually by about 2050 we should be 9-some billion, okay? 1 billion people, that's 1,000 million. It's about 3 times the amount of people that live in the United States. You need to, well, they want food, right? We don't want to starve them. But they also want energy. And more in the world as economies develop, and we like that because we don't like the idea of people being in abject poverty. They require energy. They require resources. So that adds another whole layer of problems. It's not as simple as saying we all just change because they need food. And in all honesty. The amount of food we produce right now was unthinkable just 100 years ago, actually, and 200 years ago, even more unthinkable. What have we done? We've basically industrialized agriculture. And if you are disgusted by it, I'm with you. I'm disgusted by it too. I don't like 1,000 cows in a building not being able to move. I don't like all these millions of pigs and chickens that can't do anything, that are just fed and grown so that you can buy your Kentucky Fried Chicken and I can buy my chicken or whatever at Costco. But you know how it is. They're not running on a farm as happy little animals as the fairy tale stories that we still sometimes hear or see, in advertisements when they sell their stuff. That is an illusion. There's a few farms left, but not many. The whole thing is a big industrial endeavor. And I could, as many people stop there and say, okay, down with industrial agriculture, we need to go back to old-style farms and all that. Yeah, we can demand that, but guess what? We wouldn't be able to feed 7-8 billion people. We wouldn't even be able to feed half of those. And who gets the food? We probably still get the food because we have the money to buy it, but a lot of people wouldn't get the food. So sometimes the answers are not readily there and simple. That's what I'm trying to tell you. Let's move on. Okay. To ponder. We cannot go on, I think we should not go on as if nothing is going on, because obviously something is going on and we have to think about our future and become creative. Let's move on. I need to speed on, I see that right now. So I think, and I'll make that with some other issue too, climate is only a part of our 21st century problems. Yes, it's an important part, but it is in context with other problems that we face as a humanity. Let's move on. Like I said, not reverting to pre-industrial agriculture. Next one. We also cannot afford to radically cut energy production. These people that say 10 years from now we shouldn't use any fossil fuels anymore, or 15 years from now. Well, you can say that and it sounds good, but how do you get there? How do you replace that energy by, let's say, renewable energy? Precisely how do you replace that in that short frame of time? Because if you don't, there's going to be an energy problem. Let's move on. And you don't want, yes, we need to change our economy. We need to get to a different way of doing things. But you can't kill the cow with the process. I mean, if it's the cow that gives us the milk, so to speak, in the analogy, you can't just kill the cow and then expect to continue to do fine. You have to find ingenious ways. Now, I say, luckily, the United States is a country of people that are known for being inventive and being creative, and that's, I think, where our strength is in the future. Let's move on. The other thing I wanted to briefly mention, because I only have like 10-15 minutes left, is that it's also naive to think if we in the US all get rid of plastic bags and shop with the renewable bag and don't use plastic straws anymore, and I don't want to make fun of that, that's not bad to do that, it's good, but it doesn't really solve the problem. There's another thing. Let's move on. And before I go off that slide, second to last, it has to be international, as you know, and I'll show you in a moment that US alone, we cannot do that much anymore because things have changed in the world. I say, and I want to certainly get this across to you today, in my opinion at least, and this is opinion now, this is no more science, and you realize that, but in my opinion, we shouldn't sacrifice basic liberties that we have, the freedom of choice and a good degree of our way of life as it is, in the panic that sometimes is created in having to change something quickly. Because I see that danger, and I tell you, I see it from your generation sometimes. I have essays, my students write essays, and often the solution they have for a problem is make it a law, demand it, force people to do this, force people to do that. You know what? China is the country that can do that, but we're not China. China can force their people to stay in Wuhan right now, whether they're sick or not. I don't know if you saw the video footage. There are workers going around in China that weld doors of apartment complexes shut so that people can't leave their apartment. They can't get food, they can't get out, and they're trapped in their apartment complex. China can do that. Could you imagine us doing that? No, we can't, because we are different, right? So we cannot go that route. And that again seems to be, that's the easy route. We just force everybody to do this and that because we know this and that is right. That is not the American way. That's not the way to go. Let's move on. Okay, and next click. Next click. Okay, I've talked about that, what we expect. Oh, so let me step for this here for a second. What we can expect if we don't do anything is, of course, loss of coastal areas, of agricultural land. As a consequence of that, we can expect to see mass migrations and mass environmental refugees, not only somewhere in the third world, as we call it still, but here in the US too. People wanting to move to certain areas and not move anymore to other areas, you know? Florida right now has, for other reasons, mass immigration in the sense that everybody wants to retire here because they're sick and tired of winter in the north. And you know what that does to us. I don't know how long you have lived in Florida, but I'm getting sick and tired of my morning commute getting longer every year. And of more and more neighborhoods and more cars. And, you know, it takes also from what we call quality of life. When we have suddenly areas flooded with people that weren't there before. Not to talk even about services and other things. Move on. So, yeah. Should there be draconian regulation? I think I said no already. So let's get another slide going. Another one. I want to be halfway decent in the time. So, need to stop here for a second. In the year 2007, Thomas Friedman published a book, The World is Hot, Flat, and Crowded. And I think what the genius stroke of that book is that he realized, and he says it in there, that there are several mega trends that have come together here at the beginning, it was at that time 15 years ago, at the beginning of the 21st century. The world being hot is self-explanatory. The world being flat, well, that he means that more and more countries are economically empowered and develop middle classes that have the same tastes and cultural preferences as Americans. Living in houses, driving cars, going to shopping malls, going to the movies, having air conditioning. Well, guess what? It's good for the economy and for the people who build and sell that. Energy, right? That's part of that CO2 curve going up. And you know, if we go on, he made that hot is the climate change. Next one, flat is again the middle classes. And I have some example here. Yeah, one more. So he says in his speech, and I have an excerpt which I will not play to you because I've run out of time for that. He says, in 1970 there were 3 America-like societies, including America. Societies with about, give or take, 250 million people that lived in a fairly good living standard that was very energy intensive. At that time it was the United States, Europe, and Japan. And then in Asia, up to 2000, it was mainly the so-called tiger nations of Asia, Korea, South Korea, and others. Asia added another 2 times 250 million people living like that. And then since 2000, China has added another 500 million people living like that. And so now, it's instead of 750 million, it's 1,750 million people liking air conditioning, liking cars, moving around, having houses. So there's the big other aspect of that problem. It's not just us. Actually, we are now just a fraction of the world population that lives in a way that we realize somehow intellectually is not the way of the future, because we can't, in all good conscience, continue exactly on that route. Can we go on? And crowded is, of course, population growth. Now the video will pop up. Let's just click on it going away. And I'm sorry. Thomas Friedman is really great.
Chief Sustainability Officer for Sun Microsystems.
Let's do the next slide.
He called me one day when I was working on the book, and he said, Chief Sustainability Officer,
Good. Let me just, before I go to that, say Tom Friedman talks in my excerpt here about the fact that if 1 million people more are on Earth than when he gives that talk, and each of these 1 million people, sorry, not million, billion people, 1 billion people is given one light bulb only, which they can use for 4 hours a day, it would necessitate the power generation of 25 new power plants. He says that's bringing together crowded and flat. And crowded and flat drives hot. So these things are connected. Friedman suggests in his book that the solution to solve all these problems is just to basically go to renewable energy. But I think this is too simple an idea that he proposes there. I think it does not solve all of that. Briefly, this is the CO2 emissions up to 2017 from 1960. I was born in 1960, so this is kind of like my lifetime so far. When I was born and I lived in Europe, Europe is here, the darker color. Europe and the US were the big producers of carbon dioxide, and China played no role. This is China, and yellow is India. India played no role. Let's fast forward quickly here to 2017. China now produces or releases as much carbon dioxide in the atmosphere as India, United States, and Europe combined. So us saving 10, 15, 20% of the carbon output that we do is good. It's important, but it's not sufficient. Doing something about climate change must involve, by necessity, the big ones that expose, that produce climate change gases. And we have to get China totally integrated in what is happening, or it will not work. Let's move on. Just very briefly, coal consumption, okay. The coal consumption in North America went down over the last, this is about 25 years. The coal consumption in Europe went down. Actually, the rest of the world has used a little less. This is the coal consumption in Asia. This is not just China now, that's Asia. But the big story in the last 20, 30 years was Asia, because Asia also has added 3 or so plus billion people to its populations. Let's move on one. Okay, and I have to, so this is population growth. I'm not going to stop, you've probably seen that. This is the population in the world, graphically represented right now where the distribution is. Here's the US, this is North America, Africa, Europe, and Asia. So that gives you perspective. Move on, please. We can't listen to Albert Bartlett, although he's given a great lecture there, so let's move on. And this is just short thing. Garrett Hardin, who is well known in environmental circles, published a paper in 1968 where he talks about the tragedy of the commons. The commons are things that we all share and don't charge money for. The oceans are commons. Drink water is usually commons unless you buy it in a bottle. Stuff like that. Air is the commons, okay? And he basically predicts the end of the commons if population control, if population growth is not controlled somehow. And the end of the freedom of using things. And he says here, oops, let's go back. And he says here, for example, he predicts in 1968, Yosemite Valley, plainly we must soon cease to treat all national parks as commons or they will be of no value, might be a lottery, blah, blah. There will be the destruction of the commons if we don't regulate them. And that's facing us with more and more people, more and more regulation. Next slide. I found this last week, and I'm sorry, I'll be done in 2 minutes. I found this last week on a website that is about nature exploration. Well, here we are, right? Utah wanted all the tourists and it got them, and this is about Utah's national parks, how they are flooded with tourists, and they think now of limiting access because it destroys the parks otherwise. Let's move on. This is just examples of regulations from California to India to China to Australia. Governments resort to the first thing they like to do, and that is put limitations on what people can do. Move on. I'll be done in a second. This is the tendency that most people have, unfortunately. There are complex questions, and the simple answers are the preferred ones. The not so simple answers are not followed by too many. Many people in the US and in other places think we should be China, like China, telling and legislating people's behavior and people's access to things and people's mobility and what have you. Move on. And you can click twice. Okay, I think another one. I think to sum this up here in a moment, there's one more slide and then I'm done. I think we clearly need to have renewable energy to replace fossil fuels. But we can't do that by a fiat. We need to have innovative thinking about how we do this efficiently and without causing too much interruption and disruption. Government must also encourage our economy to move towards a recycling and repurposing economy. And if you move on with the slide. And I think education of the public and decision makers is important. One more on this slide. I believe, folks, that the political debate, which is climate change a hoax or are we doomed, that political debate should be about these things and the best ways to achieve them. And that would be my wish, that we can achieve that and discuss at a different level what needs to be done and how to best do it. One more? Actually, skip that. Good. This is the last one. I wanted to end on a positive note. If you haven't heard of it, Curitiba, Brazil is named a model city for the 21st century by the United Nations. I have no time to talk much about it, but look it up. Very innovative what the people have done there, and what the folks are very happy in their city. Lots of green spaces, repurposing of buses. They came up with the idea of having the poor collect trash and exchange that for vegetables that are grown by the city and giving them public transport tickets and stuff like that. There is a lot we can think about and do, and the worst solution of the situation is to think about how we can force people to do things that are right. That's my 10 cents on that. Thank you.